Hi, Upward Bound, and anybody else that needs this. Welcome to Stoichiometry Day 5. Today we're going to go through several plans. So first of all, reaction stoichiometry. With a balanced chemical reaction, you can predict the relative amounts of the reactants and the products that are needed for or produced in the reaction in various units. That's what stoichiometry is for chemical reactions. So you have four types of problems. You have mole to mole, where you're given the mole of one substance to find the moles of another substance. Mole to mass, where you're given the moles of one substance, you have to find the mass of another. Mass to mole, where you're given the mass of one substance and you have to find the moles of another. And finally, mass to mass, where you're given the mass of one substance and have to find the mass of another. So for all problem types, there are 3 steps. Step 1, balance the chemical equation. Sometimes you'll have to even write the chemical equation, but then you have to start with a balanced chemical equation. Second, especially for mass problems, calculate the formula masses. I calculate them for everything in my equation, but that's not always necessary. But when I would do this, I would actually keep a list of all the different compounds that I ran into. It was very helpful. Third, you're going to do the plan, and I've written 4 simple plans to go with the 4 problem types, and you do the plan based on the problem type. So here are your 4 problem-solving plans. Mole to mole, you take the amount of the given substance in moles times the mole of the unknown to the mole of the given. This comes from your balanced chemical equation. They're the coefficients, and that will equal or give you the amount of the unknown substance in moles. Plan 1. Plan 2 is mole to mass. Take the amount of the given substance in moles times the mole of the unknown divided by the mole of the given. This comes from the balanced equation. Those are the coefficients. Times the molar mass of the unknown per mole of the unknown. This comes from your periodic tables. It's your average atomic masses. It's your formula mass. And that will actually give you the mass in grams of the unknown substance. Mass to mole, start with the given mass in grams times the molar mass of the given, right? And notice it's a mole per gram. It's just written upside down. Times, I'm sorry about that, times the mole of the unknown to the mole of the given. That comes from your balanced chemical equation, the coefficients again. And that will give you the amount of the unknown substance in moles. Finally, you have mass to mass. You take the mass of the given substance times its molar mass times the coefficients times the molar mass of the unknown, and that will give you the mass of the unknown in grams. Let's do some problems together. Problem 1. Given 6 moles of H2, how many moles of NH3 will be produced? Step 1 is to balance that chemical equation, right? Which is given in the problem or for the problem. So when it's balanced, it's going to be 1, 3, 2 are your coefficients. Step 2 here on finding the molar mass is not needed because it's a mole-to-mole problem. We don't have any need for the mass. Then step 3, you have 6 mole of H2, that was given in the problem, times 2 mole of NH3 divided by 3 mole of H2, and that came from the balanced chemical equation, to equal 4 mole of NH3. Problem 2, mole to mass. Given 3 mole of water, what mass of C6H12O6 will be produced? Again, you start with the chemical equation you're given. It balances to be 6616 coefficients. Molar masses, and this is where my list starts. Carbon dioxide is 43.99, water is 18.01, sugar is 180.12, and oxygen, diatomic oxygen is 31.98. Okay. So if you start with 3 mole of water times 1 mole of sugar to 6 mole of water, those are the balanced coefficients, times the molar mass of sugar to 1 mole of sugar, right? That's the molar mass. Remember on these problems, to do dimensional analysis, you multiply across the top, divide across the bottom, and that should equal 90.06 grams of sugar. Mass to mole, if you're given 824 grams of NH3 are used, how many mole of NO are produced? Again, you start with a formula or an equation that you're given. It balances to be 4546. NH3 is 17.01, O2 again, remember it's from my list, NO is 30, and water is again that 18.01. So you start with the 824 grams of ammonia, 1 mole per 17.04 grams, molar mass. 4 mole to 4 mole should be 48.36 mole of NO. Finally then, if you're given 30 grams of HF are used, how many grams of SNF2 are produced? Again, balance the chemical equation, 1, 2, 1, 1. Find the formula masses. Regular 10 is that, hydrogen fluoride, tin fluoride, and diatomic hydrogen. You start with 30 grams of HF, 1 mole to 20 grams, right? That's the molar mass. 1 mole to 2 mole, chemical equation, coefficients. Molar mass of tin fluoride to be 117.56 grams of tin fluoride. Really hope this helps. Thanks for watching.